So hi guys, this is the last session of functional programming on Scala. So the idea for this session is give you a powerful technique to testing our functional applications. So we are we are gonna start. Let me share my screen. Can you see my screen now?
Yeah.
Yes, we
Okay,
can.
cool. So as I mentioned it, today we are gonna focus on testing stuff. So I just created an example application for emailing. So the idea is we have an inbox and we have several kind of filters. So nothing special here. So the idea is start testing our applications using that technique. So the idea is try to move uh, from example based testing. That probably is the way that we used to do, and is basically find an example and try to predict the behavior of our program. That's the idea for the current stuff. So let's try to move to other technique uh, that allows the first and big difference is we don't have to care about the inputs explicitly. I mean, we have a framework for testing which allows start sending random data for testing purpose. That's the idea. We we start creating properties, which is and a definition for the specification that our program should fulfill. That's the idea. So let's try to see in an example. Let me create a new. I want to show you the current stuff using uh, examples. So this is the skeleton for our testing stuff. So for start testing using our current knowledge, probably uh, we start creating example scenarios, probably whatever that we think in that moment. Let's try to do. We have one data type email, which contains on a subject, on a email, and on a body, and a body. And also let's see our code a little bit. Just we have an inbox, which is on a sec, a collection of emails. I mean, and we have a couple filters in order to do any operation, try to move for the other folders or things like that. We create this as an algebraic data type, as you remember. Um, and that's it. So for minimum size, we only check the body. Same for maximum size, allow. And so for kind of create a whitelist or something like this is the idea. So in our current stuff, probably we start doing things like this. Create an specific example and run the code and see what happened. That's the idea. So probably we should try to do something like this. How this test will pass. But the idea here is probably for make sure that the only thing that we have here is we need to create a lot of testing for make sure that's that should work. So that probably could be really stressful. Create a bunch of similar tests for doing basically the same. So let's move to property-based testing. So the first how it works as we need to create the way to generate input data. So and for Scala, we have on our library that do this for us. His name is Scala Test Plus, includes that property-based specification. And Scala Check will help us to generate data. So let's see how probably works. I'll put all in the same file just for uh, show how the code easily. So the library provides provide us the type gen is an wrapper for generator. You know, there are a bunch of methods, but just the idea is use at the beginning. So So quickly, this code just generate an size of our word. I choose words between 1 to 100, and then try to compact in on a list in on a real string. That's the idea for this code. This generates random input data. So let's do this. I'm gonna create a size generator just for let's see. So let's do this. Email generator is just generator of email. We compose our previous generator. So just for not so far just try to create an algebra for generators. That's the idea. Try to put all our definitions in the way that we have the implementation for start sending random data. That's that try to implement here. So you have any questions at this moment?
Okay, email generator is similar. Will be sim. Then it's similar to a lambda. It's just a like a generator from TypeScript and JavaScript. I think they also have generators where each time you call it, it creates it's a function that each time you call it, it creates something different. It's
It's almost similar. You know, yeah, that's the idea. It's a generator, but that grabs our algebraic data type between this type to be able to use in the testing stuff. Yeah, almost it's the same.
hmm, okay.
this. So finally, we have also this option for choose randomly any of these my filter. Remember, this is on a trade, and we have different implementations. Probably we'll have to we will want uh, testing any of these. So let's do this also. And that will be all for our generator stuff. So let's write finally our file service property based testing test. Just doing this. We need to include this for Scala. Scala check property checks. Right. We need to include the email generators in our scope. All servers. We the main difference is we have to start thinking in what properties or what kind of laws our code should follow. That's the idea. That's the main difference. Don't think in examples, think in general rules to start testing. So, for instance, something like this. And the first difference is this. Someone we now need this function for all. We do this. And here, magically, we have a filter, and also we have some emails. So we see this. So inbox, mails, filter. Oh, let's see. Let's. Oops. Can okay, go. We run this, and now we don't see any different at the moment, but just I'm gonna include this just for showing you. It's running. So let's see. We have a bunch of inputs generated randomly. Um, because we don't have any failure in this test, we don't have any extra message. But let's try to include other property. So for instance, probably we can start doing this. Inbox. This could be the property because um, we are doing a kind of filter, so probably that could work almost the same. Just copy, paste. Probably this condition should be a little bit different. Size. Right. Also, we saw this works, but what happened if we assume that always is less? Let's see. Just for introduce the next concept. So let's see. We got an error, and the framework testing give us the extra information to make sure in which case we are good. We are getting an error. That's pretty important because we when we use that technique, probably you will start to keep in mind edge cases or things like that. Also, as you send a bunch of examples, you could have on a kind of regression test every for each per suite that you wrote. You're right. That's the idea. So this process is called shrink, and the idea is the framework start to reduce the input to try to detect the the first case when our code start failing, which is pretty nice uh, because we have extra information for our code. Probably we start checking properties that we have or we don't, uh, whatever that we found when we wrote testing. So, any questions?
Not so far.
Cool. So, finally, this, as I mentioned, it is an technique. It's not a replacement for test based on examples, because this could be really more powerful for reading and understand what our code is doing. But it's a little bit tedious. Try to detect edge cases just using our creativity for creating testing. Probably we won't do in a better than if we use a simple generator. That means um, we can use both uh, without problems. That's the idea. This is just for a mechanism to make sure our test, our code also fulfill some properties, some laws. That's the idea. That's the thing that I wanna share you. That's all that I have. I'm open for questions if you have.
Uh, just one small question here about the syntax. In line 73, for example, you are adding in line 73 at the right, you are adding a filter and emails at the parameters there. Those
Yeah,
are all the generations. Okay, the emails are what each time a new email is generated, it calls that function again, like something like a lambda, I think.
exactly.
But a minimum type gen is just yeah. I'm wrapping my head around this. Minimum type gen is just the amount of times email is generated.
No, it's other things. So this function, let me try to show you. This is using implicit stuff. So we have this configuration. That's you mean which how many uh, inputs we need? Something like this is your question.
Uh, yeah. Minimum size. So that's a property from from the assert itself, from the test case stuff itself.
Exactly. For how many
Okay.
inputs we will have. So also this start using stats definitions. I mean, we could do, okay, I'm good if uh, I have an exception in our code. I have probably yeah, an exception, but not the exception that we throw. I mean, exception that we know that it breaks our property, but we are good with that. Something for modeling business rules. Okay, let's see. That's the idea. When you start thinking in the properties that you have, you can start doing things like for this we'll say, okay, our way to do the our way to apply filters should be idempotent. I mean, probably things like that. You start thinking in general rules and try to put in the code and see what happened. This could be also be useful to start design our code or solution in based of properties or laws that we have to complete. Typically, that laws should be same as business rules. So, for instance, for when we have to uh, do any operation, we can start find properties that the business experts don't do explicitly. Just when we start creating algebras, we can start to predict that kind of things and do pretty nice stuff. That's really powerful. Probably at the beginning could be really difficult start to think in better properties, but yeah, it's try to do and practice, and I think that's all the effort that we have to put on this. Any other questions? Okay, great. I'm gonna put some exercises to the idea is you try to find laws that you know that shouldn't work, and even see that this specification fails. When we try to find that examples, you start to practice how to find better properties. Um, that's all, guys. Thank you very much for attending. If you need some clarification or something that you wanna talk in deep, just let me know.
Thank you, Giovanni.
Okay, cool. Thank you, guys.